Hello everyone, and welcome to section 8.2, adding and subtracting rationals. Now the key thing to remember with this is if you are adding and subtracting rationals, aka fractions, you need to make sure that you have a common denominator. Once you have that common denominator, you just add or subtract the numerators. Now, to find the common denominator may occasionally be tricky. Sometimes they'll be really nice and they'll already have a common denominator, but most of the time we'll have to work for it and find it. So, in order to do that, you have to find the least common multiple. Now, if this was something that you struggled with back when you dealt with fractions the first time around and every time after that, it may be helpful with these to make a little chart for yourself until it becomes more natural. So, what I mean by that, so let's break down each of these, 15a squared, b c to the third, and 20a cubed, c to the sixth, by each of its parts. So we have a number, we have, looks like we're going to have a, b, and c. So if I'm looking at 15a squared, b, c to the third, that's going to look one way, whereas 20, a to the third, c to the sixth will look another, and in the end we'll determine our LCM. So, 15 broken down as a number is 3 times 5. 20 broken down as a number is 4 times 5. For my least common multiple, I want to make sure every little piece is taken accounted for only as often as I need to. So if I only have one instance of 5 in each of them, just as I do, I only need one of them in my least common multiple. And I also have a 3 and a 5 that neither of them have in common, but will be part of my least common multiple. A squared is a times a to the third is a times a times a. For my LCM, I see I have got 3 a's for my second term, 2 a's for my second term, so my least common multiple will be a to the third, or a times a times a. So really with the variables, your least common multiple is going to be whatever the highest exponent is of that variable. So when I have a b to the first here, and no b here, b to the first is my common highest exponent. Here I've got c to the third, so c times c times c. C to the sixth is c times c times c times c times c times c. So once again we see 6 is the least common multiple compared to our 3, so c to the sixth. So my least common multiple, I've got 5 times 3 times 4, which is 60, a to the third, b, c to the sixth. For polynomials, we factor it very similarly, except it's going to look a little bit different. For this guy, we see we have common x. Once I take out a common x, I've got x squared minus x minus 2. Well, that factors further. I've got x minus 2, x plus 1. For my other one, I need a product of positive 4, sum of negative 4, so I've got x minus 2 times x minus 2, or x minus 2 squared. For my LCM, I need to make sure that I have everything accounted for. Looks like I need 1x. I have an x minus 2 here and 2 x minus 2's in my second term, so I am going to need 2 x minus 2's. And I have 1x plus 1. So I'm just trying to make sure that everything is taken accounted for and only occurs in the least possible multiples as possible, which makes adding and subtracting then a little easier. So I see a problem here, and yes, of course, they did not give me a common denominator, but I can make one. 2y is obviously not really going to break down any further, it's just kind of 2 times y. Here I've got 6 times 2 times x times y squared. So my least common multiple, which I do recommend that you kind of write out for yourself every time, is going to be 6 times 2 for my number, which is 12. one occurrence of x, and least common multiple, 2 occurrences of y. One of my denominators already actually is exactly what my LCM is, so I don't have to multiply anything because I'm not missing anything. This one, on the other hand, is missing some terms. You can either multiply by your LCM, or the way I think about it is I multiply what's missing. So I'm missing a 6, I'm missing an x, and I'm missing 1y. So I'm going to multiply that in my numerator and denominator. So 3 times 6 is 18. X squared times x is x to the third. And then I just have y that's extra. And then when I multiply my 6xy, I should end up with my LCM, which I do. I didn't have to do anything to my second part of my expression, so I just kind of leave that. At this point, I've got common denominators, so I can add my numerators. My denominator just stays exactly what it was, does not change. I don't make it 24x squared y to the fourth or any other kind of weird combination of that. See if anything in my numerator simplifies. In this case, I can't combine an x cubed y with a plain constant, so my problem is done. If you wish, you can kind of keep that good habit of saying x and y is not equal to 0. It won't really become useful until we solve equations later, and at that point it's going to be really useful. So it's just a good thing to get into a habit of. Let's look at another one, and this one is subtraction. So again, we do not have a common denominator, so let's kind of factor and see what our pieces look like. Here I have a common factor of 3. When I take out a 3, I've got x minus 5. Here, when I take out a common factor, I have a factor of 6, so I have 6 times x minus 5. For my LCM, the least common multiple between 3 and 6 is 6, since 6 is 3 times 2. And then I have an x minus 5 in both of those, so 6 times x minus 5 will be my LCM. Again, one of them actually is already taken care of by that LCM, so I don't have to do anything to the second expression. Occasionally I will have to multiply by both. We'll look at an example like that in class. But for this one, I see, well, I'm missing a 2, because 2 times 3 will get me to that 6, so I'm going to multiply my numerator and denominator by 2. Make sure you distribute. So I've got 2x plus 20 over 6 times x minus 5 minus 3x plus 15 over 6 times x minus 5. Notice we're leaving the denominator factored, but the numerator unfactored. For example, I could have factored this, but because I'm combining my numerator, I'm leaving it unfactored. So, common denominator, I'm just going to subtract straight across. If you visualize this better by writing it out, just make sure that you're subtracting that whole second denominator. If you need to distribute your negative, go right ahead. So I've got 2 minus 3x, which is negative x, and I've got 20 minus 15, which is 5. Now, similar to how we saw in 8.1, how sometimes if two things look really similar, if I could factor something out to make them the same, I will do so. So I see these are pretty darn similar. This is essentially 5 minus x, and this is x minus 5. If I factor out a negative 1 of, say, out of my numerator, I do end up with that x minus 5. got an excluded value of 5. Again, not necessary, but a good habit to get into. So these will both go away, and I'm just left with negative 1 over 6. Funny how something that looks that complicated can simplify so nicely. And a complex fraction. So, very similar. We're just going to combine our numerator, combine our denominator, and then, because it's a complex fraction, we're going to leave the first alone, multiply and flip. So if I'm looking at my numerator, I've got 1 over a, 1 over b. My LCM for my numerator is going to be just simply ab. Left side missing b. So I'm actually just going to make it really simple and write it right over it. On my right hand side, I'm missing an a, so I've got 1a over ab. I have common denominator now, so I just have to add my numerators. Now let's take a look at my denominator. I have 1, so since my denominator on the left of my denominator is b, that's just going to look like b over b. Leave the first alone, multiply, and flip. That can be a space saver in like your homework if you wish. If you do have a complex fraction, kind of like leave some room and go ahead and flip it for yourself right next to it. So check out anything that might be able to simplify if you wish. I see there's a b in the numerator and the denominator. Multiply straight across. So I've got that simplified to 1, so I just have a b plus a over a times 1 minus b. If that bothers you and you want to distribute it, since it is such a small case, / you don't have too much going on with numbers and other stuff, you can distribute it. I'd recommend not. First of all, it limits simple errors, and second of all, you don't have to. So this would be preferred, but if you really need to write it for yourself that way, you can. Just to take care of my excluded values, it looks like a and b cannot equal 0. Additionally, b cannot equal 1. So that's it for adding and subtracting. Look at a little bit more in class, and I will see you then.